everyone, myself once. Today we are going to solve the given problem based on the calculus of residue theorem from topic counter integration. Here in the question, a minus of 4 cos theta d theta. Let's solve the problem. Given integral is 0 to 2 pi and cos 3 theta upon 5 minus of 4 cos theta. When solving the given problem, first we have to know the following identity in the complex integration, that is z is equal to e की power I theta, and e की power I theta is written as cos theta plus of I sin theta, and we can also z is equal to power I theta, we can also cubing both the sides, that is z cube is equal to e की power 3I theta, and e की power 3I theta is written as cos 3 theta plus I sin 3 theta. And we can also know the following identities, that is cos theta is given by 1 by 2 z plus of 1 by z. Further we have to solve, that is 1 by 2 and z square plus 1 upon z. When we solving the given integral, we only consider the real part of the integral. So we have to consider real part, that is I is equal to, here is closed with C. C is represent the unit circle, and the unit circle is given by mod z is equal to 1. We can also draw the figure of the mod z is equal to 1, that is this is circle, this is circle, this is x axis and this is y axis and this is center. We only consider the poles lies within the given circle. First we have to put the following value, and we can also z is equal to e की power I theta differentiating with respect to theta, that is dz is equal to e की power I theta, and e की power I theta differentiating with respect to theta, that is I and d theta. From here, that is e की power I theta, and in place of we have to put z, that is z into I d theta, and further we have to find the value of d theta, that is d theta is equal to dz upon Iz. We have to put the following value in the given integral, that is cos 3 theta. We can here write, that is cos 3 theta upon 5 minus of 4 cos theta and d theta. Here is also d theta. We have to put the value, that is in place of cos 3 theta we have to put z cube, that is z cube upon 5 minus of 4, and in place of cos theta we have to put 1 by 2 bracket z square plus 1 upon z, by 2 and z square plus of 1 upon z, and here is in place of d theta we have to put dz upon Iz. Further we have to solve. First we have to cancel out 2 to 4, and the remaining is I is equal to close integral with C, that is z cube upon, here remaining we have to take a LCM first, that is 5z minus of 2 z square plus of 1 upon z, and here is dz upon Iz, and from here we have to cancel the terms, that is z to z is cancelled out, then the remaining is close integral z cube upon, here is 5z and multiplying minus 2 with z square plus 1, that is minus of 2z square and minus of 2, and here is remaining dz upon I. And from here in the denominator we have to take minus common, that is I is equal to, and minus common and taking I is also into outside, it is 1 upon of minus of I close integral c and z cube, and from here we have to take common minus 1, that is minus 2z square is plus 2z square, and plus of 5z is minus of 5z, and plus of 2 is given by minus of 2 is given by plus of 2 dz. Further we have to factorize the denominator. We can break into the factor form, that is here is minus of 1 upon I, and I we know in the complex integration, that is I square is equal to minus of 1. So we have to put in place of minus, we can put that is I square, that is I square upon I, and close integral c z cube upon, we have to break into a factor form, that is 2z square and minus of 4z and minus of z plus of 2 dz. And from here, that is I to I square is cancelled out, then the remaining is I here. Then further we have to solve, that is I close integral z cube upon, here we have to take common 2z square minus of 4z, that is 2z is taking common, that is z minus of 2, and from here that is minus of 1 is taking common, that is z minus of 2 dz. Further we have to write, that is I is equal to I close integral c and z cube upon, we have to take 2z minus of 1 in one bracket, 2z minus of 1 in one bracket, and z minus of 2 in another bracket, this is dz. From here we can consider, that is I close integral z cube upon, from here 2z minus of 1 we have to take common minus 2, only 2, that is z minus of 1 by 2, and here is z minus 2 is already present, and dz. Further we have to consider, that is close integral I is taken to here, that is I into z cube upon 2. Once again we have to consider the I z cube upon 2 and z minus of 1 by 2 up into z minus of 2 is fz dz. Further we have to find the simple poles. Further we have to find simple pole by equating the denominator is equal to 0. So we have to equating the terms denominator, that is z minus of 1 by 2, and once again we can also from here equating the denominator is equal to 0, that is 2z minus of 1 is equal to 0 and z minus of 2 is equal to 0, and from here that is 2z minus 2z and minus 1 is taken to right hand side, that is 1, and z is equal to 1 by 2, and the second we have to get z is equal to 2. And the given circle we close with C unit circle, and here is z is equal to 2 is not within the circles, so we have to consider only z is equal to 1 by 2, and we have to find the residue at z is equal to 1 by 2. find residue at z is equal to 1 by 2. That is given by limit z tends to 1 by 2, and here is once again 1 I by 2, that is I by 2 is present here, and we can z minus of 1 by 2 into z cube upon z minus of 1 by 2 into z minus of 2. We have to put in place of z 1 by 2, we remove these two brackets. When we have 2 vanished, when we have to put z is equal to 1 by 2, and the remaining is I by 2 into z cube upon z minus of 2. Further we have to put, that is I by 2 in place of z cube, we have to put 1 by 2, that is 1 by 8 upon, here is z, in place of z we have to put 1 by 2 minus of 2. Further we have to solve, that is I by 2, and from here that is 1 by 8 upon, here is taking LCM, that is 2 to the 4, and minus of 4 plus 1, that is minus of 3 by 2, and from here I by 2 into 1 by 8 into minus of 2 by 3, and from here that is 2 to 2 is cancelled out, then the remaining is I upon, once again minus I upon 24. This is the residue at z is equal to 1 by 2. Further we have to use Cauchy residue theorem. Using Cauchy residue theorem, that is integral fz dz is equal to 2 pi I into sum of residue. This is represented by r plus, here is r plus is represented by sum of residue, and here we have to find 2 pi I, and the residue we have to calculate, that is minus of I upon 24, and from here that is 2 12 are 24, and I into I is I square, and I square is given by minus of 1, and here is already present minus of minus, so minus is plus, that is pi upon 12, and further we have to write, that is 0 to 2 pi and cos 3 theta upon 5 minus of 4 cos theta is equal to, cos theta d theta is equal to pi by 12. This is the required solution of the given problem. Thank you class, and thank you for watching.